The next skill we're going to move on to is looking at the signs of the trigonometric functions in the four quadrants because it's very predictable. For example, in quadrant 1, if I was to draw any triangle, including my quadrantal angles, okay, but in quadrant 1 here, and I was to have my opposite be my y value, the y is in a positive direction. The x is in a positive direction, and the radius is always positive. So if I look at the ratio of opposite to hypotenuse, or y to r, it's always going to be a positive over a positive, so that sine and cosecant, which is just the reciprocal, would both be positive. If I was to look at cosine and secant, it would be x over r or r over x, but it would be a positive over a positive, which would also be positive. If I looked at tan, it's y over x, or opposite over adjacent. So again, it would be positive over a positive, and so everything would be positive. In other words, in quadrant 1, all of the trig ratios are positive. And that's because there's nothing to make them negative. If I move into quadrant 2, I have a negative x value, a positive y value, and a positive r value. Well, what's that going to make be negative? Well, the only ratios that deal with x would be the cosine and the tan. So again, if we went through and did these, sine would be y over r. It would be positive over a positive, which means that sine is still positive. Whereas cosine is x over r, which would be negative over positive, or if you're looking at secant, it would be positive over negative, but regardless, it's negative. Tan is y over x, or opposite over adjacent, which would be positive over negative, which is negative. In quadrant 2, the only ratios that are positive are sine and cosecant. We don't really worry about the cosecant, secant, and cotan. They kind of go along for the ride. Just know that they have the same sign as the primary ratios. And so we're going to say that the only one that's positive is sine. So in quadrant 2, the only ratio that's positive is sine, because sine is y and r, and the only thing negative is x. Let's look in quadrant 3. In quadrant 3, my y value becomes negative, and my x value is negative as well. My radius is always positive. So if I was to look at sine, now it's negative over positive, right? Y value is negative over a positive r value. Sine is a negative ratio in quadrant 3. Cosine is x over r, or adjacent over hypotenuse, and it's also negative. Whereas tan, because it's y over x, it's going to be a negative over a negative, which means tan is positive in the third quadrant. The only ratio that's positive in the third quadrant is tan, and of course, cotan. In quadrant 4, what happens? Well, my y value is negative, but my radius is always positive. So this time, the only ratios that are going to be negative are ones that involve the y, which would be sine. So negative over a positive is negative. And then cosine would be positive over positive, which means it's positive. And then tan is y over x, so it's going to be negative over positive, which means it's negative as well. The only ratio that's positive in quadrant 4 is the cos ratio. Now, these never change. All of your trig ratios are always positive in quadrant 1. In quadrant 2, the only one that's ever positive is sine. In quadrant 3, the only one that's ever positive is tan. And in quadrant 4, the only one that's positive is cosine. That leads us to what we call the cast rule, or I like to call it the cast rule, because in quadrant 4, cosine is the only one that's positive. In quadrant 1, all are positive. In quadrant 2, I had to think about that, sine is positive. And in quadrant 3, tan is positive. C-A-S-T, cast rule. So it's called the cast rule because ideally we would start in quadrant 1, but then it would be the Astica rule, which doesn't make a word. So we start in quadrant 4 and read counterclockwise to make the cast rule. It's a little awkward. You will see some teachers will teach this and they'll say all students take calculus, or you could make, some other little mnemonic device to remember it. So if you want to start in quadrant 1, you can't use the CAST rule, but you could use all students take calculus, or, make up your own sentence, whatever you want it to be. But once you know this CAST rule, you can predict the signs of the trig function values for any given angle. So for example, if I was going to talk about negative 37 degrees, negative 37 degrees is in quadrant 4 because you're reading in a clockwise direction. And if I think about my CAST rule, that means that the positive ratios for negative 37 degrees would be cos and secant, whereas everything else would be negative. So negative would be sine and cosecant and tan and cotan. And it's kind of a weird exercise to do, but it's going to apply. It's kind of like baby steps, right? You got to learn all the fundamentals, and then we get to apply these and why we care about this later. So just be okay with this rule. Now, if you wanted to check it because you didn't quite trust it, you could grab your calculator, make sure your calculator's in degrees, and hit sine of negative 37. I get negative 0.6018. It came out as negative, but I knew that already. I could predict the sign of the trig function value, right? And that's all we're doing here, is being like, hey, I can do some of the things the calculator is going to do, but with knowledge. Why does it come out negative? And that's what's important with this. So 256 degrees, if I was to figure out which quadrant that's in, I'm going to guess that it is quadrant 3, right? And the way that you could check is to find the reference angle. So if I do 256 minus 180, ooh, I put 2,560. 256 minus 180, that gives me a reference angle of 76 degrees. Since it's less than 90, I know that I am in quadrant 3. If I then look at my CAST rule, I could tell you that the ones that are positive are tan and cotan, whereas the negative ratios would be everything else. So sine, cosecant, cosine, and secant. All right, again, kind of a weird exercise, but trust me, we're going to use this CAST rule more and more, so this is just your first introduction to it. This next question I kind of debated. It's a little bit tricky, and I sort of debated whether it was a good question to ask, but I think it's a way of, beginning to apply this knowledge. So what you're supposed to do is you can use a calculator, but you're not allowed to use the trig function keys. And I want you to find the trig function values for 330 degrees. What? So what we're saying is that in quadrant 1, this angle of 27 degrees has a ratio of opposite to hypotenuse of 0.4540, adjacent to hypotenuse of 0.8910, and opposite to adjacent of 0.5095. And you're not supposed to know what the opposite, the adjacent, and the hypotenuse is. You just know what the ratios come out as. And they're saying, okay, well, what if it was 337 degrees? Well, 333 is in quadrant what? Right? 4. So if I wanted to figure out the reference angle, I would do 360 minus 333, and can anybody guess what you're going to come out with? 27 degrees. So what we're doing is we're saying, hey, same reference angle, different quadrant, what would the ratios be? So all of a sudden, if you realize that we are going to use the CAST rule, in quadrant 1, everything is positive, but in quadrant 4, the only one that's going to be positive is going to be cos. So right away, if I was to write sine of 333 degrees, I'm having a hard time reading that number, it's going to be the same, but negative. The cos of 333 degrees is going to be the same and positive. And then the tan of 333 degrees is 0.5095, but negative. So as soon as I went from quadrant 1 to quadrant 4, I had to watch my signs. So the values are the same, but cosine's the only one that says positive. Then the reason they say use a calculator, and this is the part where I was like, ugh, do we really have to do this? But it was hard for me to assign the question without being like, well, could you also find cosecant, secant, and cotan? And it's not that hard. So to find cosecant of 333 degrees, it would be the reciprocal of this, right? Because if this is opposite over hypotenuse, then if I wanted hypotenuse over opposite, I would just flip it. And so this is where they say you can use a calculator. I mean, really, I think this would be a great answer. But what they want you to do is do 1 divided by negative 0.4540, which gives you negative 2.2026. We'll just keep those same 4 decimal places. And then we do secant. So secant will be 1 over positive 0.8910. 1 divided by 0.8910. And I get 1.1223. And then lastly, cotan of 333 degrees would be negative 1 over, or 1 over negative, it doesn't matter. I guess I should stick with that. 1 over negative 0.5095. Which if I plug that into my calculator, 1 divided by 0.5095 gives me negative 1.9627. So really what this question is stating is, okay, this is in quadrant 1 with a reference angle of 27. This is in quadrant 4 with a reference angle of 27. The trig function values stay the same, but you have to change the sign. And then if you're doing the reciprocal trig function, then you have to flip the ratio. Awesome. All right.